Hey guys, Mr. Went back again. In the last video, I basically told you how to calculate some of these things. Now we're going to do a quick little example. So in this example, we're determining the following information for this digital signal that we have here. We're going to be asked to find the amplitude, the period, the frequency, how long it was at high, how long it was at low, and what the duty cycle was. Okay. So basically, if we look back and we look at our digital signal, from our first screen, we can see that the amplitude is how tall our signal is. And so if I look on here, I can basically calculate out that my amplitude goes from about the midpoint of that division down to that division. I'm going to call it amp for amplitude. Now, I don't know how much that is, so I got to look over here, and according to my Y position here, it's 2 volts per division. So for my amplitude, I know that the amplitude equals 2 volts per division. And we're going to multiply that out because we have more than 2 divisions. We have 1, 2, and a half. So we'll multiply that by 2.5. Okay, so we get that out, and then what we end up with is an amplitude of 5 volts. So 2 times 2.5 is 5 volts. So that gives us our amplitude. So we're going to say that is 5 volts. The period is, if we look on here, we have our time high, so we'll just look here. It starts here, so the period will start right there. Basically goes to that point there, so there's our period. And the period again is marked in T, so T is equal to how many divisions? Well, we have 1, 2, 3, 4 divisions. Okay, and according to this, in our X position, we have 2 milliseconds per division, so times 2 milliseconds. And that gives us a T of 8 milliseconds. So our period, T, is 8 milliseconds. Okay. Now the frequency is a little bit different. So frequency, we have F, and the frequency is equal to 1 over the period. So 1 over our period, which was T, so we'll plug that in there, which was 8 milliseconds. And basically, 1 over 8 milliseconds is equal to 125 hertz. Okay. So basically, 125 hertz, that gives us F. So we can plug that in, frequency. Let's check that out and just verify. So 1 divided by 8.125, because it actually gives you 0.125 seconds, and that's not a whole number, so we move it 3 places over, and because it's in milliseconds, so that would actually be, technically that would be 0.008. Okay, so 1 over 0.008 gives us this 0.125, so we have 125 hertz. This thing happens 125 times a second, so 125 hertz. And then the next two are pretty easy, time high and time low. Well, we know that this right here is our time high, so from there to there, because that's how long it was in the high state, or 5 volts. So time high is equal to 1, 2, and basically about a half a division. And so we're going to look on there. And basically, what do we have? 1, 2.5 divisions. So time high is 2.5 times 2. Well, that gives us 5. So we'll have a time high. I keep hitting this right click button. So time high is equal to 2.5 divisions times each division is 2 milliseconds. And so basically our time high is 5 milliseconds. And then we would do the same thing for time low. So we'll get into a clean area. We'll look at time low. This is time low. And we basically have 1.5 divisions. So we take this same equation, and this time time low is 1.5 divisions times it's 2 milliseconds, so 2 milliseconds per division. So time low is 3 milliseconds. So time high was 5 milliseconds. Time low is 3 milliseconds. Okay. And then the last thing we do is we're going to find the duty cycle. The duty cycle for this is measured with time high over the period times 100%. So the duty cycle is DC equals time high over the period times 100%. So basically, time high, we go down here, we had 5 milliseconds. So 5 milliseconds divided by the period, which was 8 milliseconds. And let's see, 5 divided by 8 gives us 0.625. Okay, and that, if you multiply that by 100%, 2 spaces, we have 62.5% is our duty cycle. So we plug that in, 2.5%. And then we've just basically determined what we need to know from this digital signal. So that's the kind of stuff you'll have to do in your sheet. So hopefully this was helpful, and we'll see you next time.